or position in space. On the other hand, all beginning, generation, all formation of new thought objects, and all unification of the same requires a material carrier. Hence, all thinking comes to pass at a determined place. Thought is a process within ponderable matter. Our external experience, the facts of our external perception, which must find their explanation in the processes within ponderable or gravitating matter, are 1. Universal gravitation, 2. The universal laws of motion. Something lasting underlies each act of thought, something which, however, is manifested only under the specific occasion of memory as such, without exerting any enduring influence upon phenomena. Therefore, with each act of thought, something lasting enters our soul, something which exerts no enduring influence upon phenomena. On the other hand, our external experiences about ponderable matter can be explained if it is assumed that a homogeneous substance fills the whole of infinite space and constantly flows into ponderable matter and vanishes.
Riemann's approach was to take creativity per se as an object of experimental study and to apply the workings of the mind of man in order to understand the mind of its creator, whose mind in turn lay behind the functioning of the physical universe. Riemann's clear rejection of the mechanistic fallacy of Newton and Laplace made possible his most crucial discoveries in physics. As we have heard from him here, and as he himself says in his groundbreaking habilitation dissertation on the hypotheses which lie at the foundations of geometry, it was a direct study of the creative processes of the human mind which led him to the discovery that space and time were not self-evident existences. This recognition was what made Riemann uniquely capable of inventing the mathematical language which later became necessary for the formulation of Einstein's general theory of relativity.
But if all modern science depends upon these discoveries of Riemann, which resemble more the approach of Kepler and Plato than of Newton, how can it claim to have reduced those creative faculties of the human mind to the mere behavior of subatomic particles? Perhaps the picture which modern science presents of the universe is nowhere near as complete as it seems.
In fact, the view of science which was promoted by Kepler's detractors was riddled with conceptual holes. This was recognized by, among others, the great scientific minds of Max Planck and Albert Einstein. Planck saw in the atom the same problem which Kepler had recognized in making the leap from astronomy to astrophysics. The world of the atom, like the organization of the solar system, was not directly accessible to human sense perception. Instead, the paradoxical projections of this invisible domain onto the separate senses of vision and hearing needed to be investigated to reveal their underlying harmonic character.
Can such a deeper conception of science be the basis for a guiding philosophy to live one's life by? We find the surest answer to this question by looking back in history to the men who embraced such a conception of science as their own, and for whom it indeed served this purpose. Among the numerous physicists for whom their science helped them endure and ennoble a miserable life, we remember, in the first rank, Johannes Kepler. Outwardly, he lived his life under beggarly conditions, disappointment, gnawing hunger, constant economic pressure. What kept him alive and able to function through it all was his science, but not the numerical data of the astronomical observations in themselves, but his abiding faith in the power of a lawful intelligence in the universe. One sees how significant that is in a comparison with his employer and master, Tycho Brahe. Brahe possessed the same scientific knowledge, the same observational data, yet he lacked the faith in the great eternal laws. Thus, Tycho Brahe remained one among many worthy investigators, while Kepler was the creator of the new astronomy.
This resistance by Planck to what became the insane formulations of quantum mechanics was communicated to his student, the psychologist Wolfgang Köhler.
The physicist likes to give this impression a disturbing touch. The pavement, he would say, on which you walk along the street, is for the most part empty space. In so much emptiness, tiny electric charges rush about here and there, and it is only the ever-repeated impulses of such charges which keep your feet, and all the rest of you, above the ground. When a physicist tells us that a macroscopic object is really a swarm of particles, do we understand him correctly if we assume that atomic physics does not recognize the existence of definite macroscopic objects? Are macroscopic objects dissolved into particles? At first, it might appear as though only one aspect, either the microscopic or the macroscopic, could correspond with physical facts. And yet there is no such alternative. Both the demarcation of macroscopic objects and their atomic constitution are legitimate notions which are well founded on physical evidence. Particles do occur as separate entities. They are also real parts of macroscopic objects. But functionally, they are not quite the same entities in the second as in the first case. And we still trust the particles themselves more than their fields, as though, in the case of the pavement, we could safely tread on particles, but should beware of mere fields. As a matter of fact, insofar as particles are known to be fields and field structures, they fill the volume of a macroscopic object completely. It is only as a field continuum that it coheres. And the support which the pavement gives to our feet is entirely due to this continuum. It will not yield unless much stronger forces than our weight are applied.
Köhler was trained extensively in the German classics, which for him included the work of Riemann and Weber, as well as that of Bach and Beethoven, but not, for instance, Wagner. This standpoint allowed him also to recognize that the paradoxes of quantum mechanics were only pseudo-paradoxes, logical consequences of a fallacious worldview which rejected the factual existence of human creativity as an independent driving principle in the universe. Köhler and his collaborators identified the fundamental unit of human thought as the Gestalt. The German word Gestalt means form or shape. In the psychology of Köhler, it indicates that what is recognized by the human mind is never a collection of individual sense impressions, but rather a whole, which is, in a certain very specific sense, greater than the sum of its parts.
In Gestalt psychology, we distinguish three major traits which are conspicuous in all cases of specific organization or Gestalt. Phenomenally, the world is neither an indifferent mosaic nor an indifferent continuum. It exhibits definite segregated units or contexts in all degrees of complexity, articulation, and clearness. Secondly, such units show properties belonging to them as contexts or systems. Again, the parts of such units or contexts exhibit dependent properties in the sense that given the place of a part in the context, its dependent properties are determined by this position. May I use an old example once more? A melody is such a context. If it is in A minor, for instance, minor is a property belonging to the system, not to any note as such. In this system, the note A has the dependent trait of being the tonic with its static quality. We can analyze the melody, but not in independent parts. That would be destruction of the melody. Its minor character, for instance, would be lost.
This obvious fact of human creative thought is evident in all forms of classical composition and forms the basis of the mind's ability to communicate and receive profound ideas, as opposed to just a string of sense impressions or information. Its existence was frantically denied by reductionist psychologists in Curler's day, who instinctively saw it as a threat to the political philosophical worldview which they were promoting. Nonetheless, said Curler, the Gestalt is a scientifically verifiable fact of human creative mentation, even of human sense impression. Moreover, said Curler, this phenomenon in the human mind must necessarily have corollaries in both physics and biology, if only because it is through the human mind, and only through the human mind, that we are able to arrive at the truths of these sciences. In biology, this was most clear. Life could be reduced to non-living parts, just as a musical line could be reduced to its component notes, in the first place by killing the organism, and in the second place by killing the musical idea. But the living organism qua living organism was more than the sum of those parts. In fact, a newly dead organism consists of exactly the same parts as the living organism which it was just a moment before. Many embryologists, such as Hans Driesch, were well aware of the fact that the growth of the living organism was impossible to explain mechanistically. The pattern of growth and development of a living embryo unfolds as if with the final stage of its development already in sight. This concept was developed by subsequent thinkers such as Hans Spemann, Ross Harrison, and Alexander Gurvich into the concept of the morphogenetic field, leading them to apply to living processes the same concept which had earlier been applied to universal gravitation, the idea of potential. Some of these thinkers, including Curler, took this a step further and recognized what Riemann had already recognized several generations earlier. The concept of potential represents a physical gestalt, a single idea from which an infinite number of individual forces could be derived, in the same way as points can be derived from the intersection of bodies. But that single idea was in no way composed of those individual forces, any more than bodies are composed of points. Returning quickly to this geometric example will provide us with the conceptual material necessary to understand this point. The intersection of two bodies forms a surface. Since this intersection can occur at any location within the body, we are compelled to say that the body is composed of these surfaces. But let's try the inverse. Let's try to actually construct a body from surfaces. Now, a plane is that which has zero height. Therefore, no matter how many of them we stack on one another, we will never be able to construct a solid body. That is, 0 plus 0 equals 0, no matter how many zeros are added. In that sense, we may say the geometric body